So hello and welcome to our panel on energy. As Professor Hennessy already said, and I think we all agree, energy is one of these areas where we're going to face many critical challenges in the future. So roughly speaking, these challenges will come in two fronts. It's the energy production and the energy consumption. So on the production front, there are many experts who are trying to unlock new sources of energy for us. And there's also a continuing, very important effort to increase the production efficiency for the resources that already exist but are very scarce. And then on the consumption side, there are many experts who are trying to help us consume energy more efficiently and be more sustainable. Of course, as it was mentioned before, climate change and the growing population play a very important role on both sides of this equation. And of course, any of these advances in energy technology can only become a reality with the help of the right policies. So I'm very excited to say that our panel today is a great example of the diversity of challenges that we see today in the energy space. Please join me in welcoming our distinguished panelists. Please briefly introduce everyone first, starting from Mohammad. Dr. Mohammad Shahvali is currently a project manager at QRI, where he leads an integrated team of engineers and geoscientists. Mohammad received his bachelor's in petroleum and electrical engineering at Sharif University, his master's degree in petroleum engineering from the University of Calgary, and his PhD in petroleum engineering also at Stanford in 2012. After Stanford, Mohammad has been involved in several academic and industry positions. His technical areas of expertise are data-driven reservoir management, field development planning, and analytical and numerical modeling of oil and gas reservoirs. Thank you so much for being with us. Dr. Hedi Razavi is the co-founder and COO of Keewi, a company with a mission to transform the indoors into living and delightful communities that restore the pristine outdoors. Prior to founding Keewi, Hedi led a global team in the design and commercialization of various novel medical devices at St. Jude Medical in Germany. And I think that was where she developed an interest in the energy industry. Hedi graduated with her bachelor's degree from UC Berkeley and received the Departmental Citation Award, which is the highest recognition bestowed upon an undergraduate student. She completed her master's and PhD at Stanford as a National Science Foundation Fellow and a Siebel Scholar. Thank you so much for being with us.
Thank you.
So, Dr. Pooya Azadi is leading the efforts of the new Stanford Iran 2040 project. He studied chemical engineering at the University of Tehran and the University of Toronto, where he completed his master's and PhD. After his graduation and prior to joining Stanford, Pooya worked as a researcher at the universities of Oxford, Cambridge, and MIT for 4 years. Pooya has a strong interest in the areas of energy and the environment, where he has published a few dozen research papers and reviews. So just a quick note about the Iran 2040 project. It is an academic initiative that serves as a hub for researchers all around the world to conduct research on economic and technical matters related to the long-term development of Iran and to evaluate their possible implications in a global context. They have so far published 4 reports on the future of Iran's oil and gas sectors, agriculture, and population. Thank you so much, Pooya, for being with us. And finally, Dr. Reza Fassihi is a distinguished advisor with BHP Petroleum in Houston, where he's responsible for subsurface technical assurance on global projects. Prior to this role, he was the unconventional technology manager with BP. He has over 30 years of experience in petroleum research and development, as well as field application of reservoir management best practices. He has co-authored more than 40 technical and scientific papers. He's also the co-author of a new SPE monograph, Low Energy Processes for Unconventional Oil Recovery. He holds a bachelor's degree in general engineering from Al-Wadan Institute of Technology, an MS in chemical engineering, and a PhD degree in petroleum engineering from Stanford. Thank you so much for being here. I should just say that I think this is a very special panel for me. Two of our panelists, Mohammad and Reza, they traveled from actually 2 different places just for today, and they're flying back in the afternoon. So Mohammad was supposed to be in Colombia, and Reza just flew in from New York last night. So thank you for that. And we also have 2 former PSA members on the panel, Hedi and Mohammad, so I'm very excited about that also.
I was thinking about a way to highlight a problem that we all face and we all have experienced. And what I came up with was actually air pollution. This is something that I assume a lot of us here have seen, especially in the context of what we have in Iran and especially in Tehran. So these are forms and pictures that are not very foreign to us. Little did I know at the time that I didn't have to go so far to Iran to sort of think about this, that unexpectedly dry climates, high winds, and hot weather actually made this, a disaster very close in our backyards come true. So what that led to was essentially pictures that are not very different between Iran and here in California. And so I'm sharing all this to say we have a problem. And as unfortunately, as controversial as that may be, climate change is something that's happening. We're experiencing it. And people on this panel are, of course, tied to it in different ways, and we're all tied to it in different ways. And so one thing that this problem needs is a revolution, and that revolution is going to be looking at changing how we create new resources, how we get new resources, and also how we use them. So since the Industrial Revolution, we have been using traditional forms of energy that have definitely gotten us to this point, but they're now not working for us any longer. They're affecting our environment, they cost a lot, and there just isn't enough of it for the growing population. And what we need is a change in the forms of energy that we get. So the last few decades have done a great job of showing feasibility of alternative forms of energy, whether it's solar, whether it's wind. But we also need to look at how we use the energy that we have. And that is something that is very familiar to most people in the Bay Area, especially, in that there's a revolution being built in how we use resources and how we share resources that we have. So in the context of what I have shared with you, it sort of highlights where we, at Keewi as a company, where we see us going and where we see we can, having an impact. And it's really in that last bucket and how we use electricity, and so how we use the energy resources that we currently have or already have. At Keewi, we focus on the largest consumer of electricity, and you may be surprised to know that our buildings consume somewhere around 47% of the total energy, at least in the U.S. They are big energy hogs, and there's a lot of effort in trying to understand how much energy do they use and why do they use so much of it. The Department of Energy had a study a few years ago in which they looked at 3 different categories of energy consumption. Traditionally, HVAC, which stands for heating, cooling, and ventilation, has been the greatest draw of electricity, and after that it's lighting. Thankfully, with new technologies like LED lighting or better building envelopes, those trends have been stabilizing and have been reducing. There's a third category that up to this point has been quite ignored or not really looked at, but it's actually a growing pain, and it will continue to grow as we all but continue to use a lot of electronic devices. So everything that you plug into the wall outlet, especially in a commercial building, draws now somewhere around 40 to 60% of that building's usage, and about 50% of that resource is wasted. You may wonder why, and it might not be a big surprise that it's because of us, because of the occupants. We don't have the infrastructure, the resources, or the incentives to really eliminate that usage. And so at Keewi, what we focus on is aligning incentives of the building occupants and the building managers with the understanding that ultimately we would be able to reduce consumption for commercial buildings. So we empower occupants to bring about change, to take responsibility for their usage, and in the process, feel good about it because they can do their own, they can do what they feel is right. I won't spend a whole lot of time here because I know we're short on time. But in the short period of time that we have been around, we have been fortunate to work with a lot of leading edge institutions. Stanford was actually, I can't say it the first, but they were the second customer that we worked with. And that was a great honor. So we have made a lot of progress in bringing this technology to building managers and building owners. And so with that, I'd be happy to talk more about what we do at Keewi and also the energy field in general on the panel. So I'm looking forward to that.
All right. Well, thank you for having me here. It is truly an honor to come back. Last time I was here on campus, it was back in 2012. The last day was when I guess a few days before I left was when I defended my PhD thesis here in Stanford, and then I never came back because I was so frustrated with my advisor. But it's really good to be back, finally, after all these years. So Lily mentioned in her opening remarks that this place in this area is a bubble. And I want to also echo on what she mentioned. Please don't take it for granted. For those of you who are students, even if your advisors are giving you a hard time, please hang in there. And this is really a good area to be with, not just because of the environment, but also because of the people. So what I want to talk about today is, well, a little bit of introduction of myself. I think Amir Hossein gave a nice introduction. I work at a company called QRI, Quantum Reservoir Impact. We're based in Houston. What we do is basically we provide data-driven solutions for the energy industry. We provide a lot of services to a lot of energy companies, mostly internationally and also national oil companies. What I want to specifically talk about today is applications of data-driven solutions and machine learning, artificial intelligence in the oil and gas industry. I've stolen this slide from Oxy, the source is down there, but I thought it would illustrate my point pretty well. Just like any other industry, the oil and gas industry, the energy industry is going toward dealing with a lot of data. It's been like that forever, but in the recent years, with the advancement of data-driven solutions and more intelligent and smart ways of solutions, basically the industry has been revolutionized. If you look at this slide here, we can see that data-driven, big data analytics play a key role in various phases throughout the lifetime of essentially providing solutions for our global energy demands. The first step starts essentially with data collections and profiling. We are dealing with energy industry is one of those industries where the amount of data and the volume of data is humongous. Think about, for example, an operation that is going on a daily basis. Every day, tons and tons of data is collected. The data needs to be essentially a QC'd, needs to be organized. And the first step in making sense of the data is essentially the most important one. There are a number of statistical methods that we use throughout the projects that we work on, and that also has made an impact in the way we think about data and the way we think about providing more efficient solutions. Here's an example that I've put together again. If you look at the workflows that are going on in the energy industry right now, we can see that we're talking about field development plan and optimization. We're moving toward more efficient solutions to address the global energy needs. This is an example of a reservoir with, for example, tons of wells where you have injectors, you have producers. And what you do on a daily basis, you collect this data, you process the data, and if you look at the, some of the sources of the data, again, you have temperature, you have pressure, you have injection, you have production. You process this data and use some proxy models to essentially try to forecast the behavior of these reservoirs, try to understand how they behave under various circumstances. And then in a feedback loop, you essentially take this data, go through some sort of an optimizer, and try to make your development strategies more and more efficient. And this is a loop that will continue on a daily basis. This, perhaps maybe 10, 15 years ago, was something that industry would never think that would come about. But with the advancements of, again, algorithms and data and methods such as artificial intelligence and machine learning, this has become possible. And this is, again, something that is going on a daily basis. So you do this optimization, you go through this loop, and it has essentially tremendously changed the way we view the efficiency in our industry and the way we operate these reservoirs. So I would be happy, during the discussions to talk about more in details about data-driven solutions and how we take advantage of these advancements in our industry.
Thanks, Mohammad. I think Pooya's slides are next.
سلام عرض میکنم خدمت همه دوستان، امیدوارم کارتون خوب باشه. Thank you, Emerson John, thank you, Nargis John, and all other friends for inviting me here. So I don't have a cool product to talk about. Instead, I'll be talking about some of the research that a few friends and I have conducted at Iran 2040 initiative at Stanford. Because I'm in this energy panel, I keep it. I only talk about the energy in Iran, petroleum industry more specifically, and I'll just provide you some high-level stats about the industry. So Iran is currently producing about 3.8 million barrels of oil per day, which is equivalent to about 4% of the global production. And this value is about 1 million higher than its low during the sanctions in 2014, 2015. And then about half of this 3.8 million, or to be more precise, 1.8 million barrels per day, is used by the domestic market to meet the domestic energy need. And about 2 million barrels is left for export. So at an oil price of about $50 per barrel, this means that Iran earns about $100 million per day from the oil export, which is equal to about $36 billion per year. Now, if you, knowing that 10 to 20% of the revenue goes to cover the production costs, Iran roughly makes about $30 billion each year just by exporting oil. And then to put this into context, the government of Iran pays about $15 billion each year in cash transfer, or yaranay naqdi. So in other words, about half of the petrodollars that Iran makes just directly is distributed directly to the people by cash. So a study that we conducted last year, it's a detailed study, field by field analysis, showed that on average, the Iranian oil fields the production from Iranian oil fields declined by about 6%, which means that in absence of new investment, the production a year from now would be 250,000 barrels less than the production level today. So with that said, we are, in terms of the outlook for the oil industry, we are anticipating that Iran's production will continue to fluctuate about 4 million barrels a day. And if all the exploration, development, and enhanced oil recovery projects will turn out to be successful, then Iran can add another 500,000 to its production to increase it to reach 4.5 million barrels a day, which is roughly about how much Iraq is now producing. Now moving on to gas sector. Let's see. Moving on to the gas sector, the outlook seems to be a bit more promising and optimistic. Iran has, as you guys know, Iran has the largest resources or the largest reserves of natural gas in the world. And with the development of the Pars Junubi or South Pars, Iran was able to boost its production massively from 200 million cubic meter per year to 750 in 2016. And we forecast that this number goes up to over 900 by 2020. The demand is also growing very rapidly. And it's surprising to know that Iran, until recently, was a net importer of natural gas. And because of this growing demand, we don't really anticipate to see Iran as a major player in terms of gas export in the future. So that's a brief overview of our two projects that we have done, one on oil and the other one on natural gas and electricity. And I'm happy to dive deeper into this if anyone was interested. Thanks.
First of all, I really like to thank the organizer of this great meeting for inviting me. It's a pleasure to be here. And it's a pleasure to be amongst Iranians who have graduated, who have been associated with Stanford. Because for me, Stanford is a second home. My wife is from here, graduated from here. My son came here. And believe me, I'm dedicated to Stanford. So it's a great place to be here. And when I got the invitation, I said, by all means, I'll come for two reasons, Iranians and Stanford. Okay. The second thing is, I just want to also let you know that I'm the ex-president of APPIH, which stands for American Petroleum Professional of Iranian Heritage. It's an organization that is for Iranian community who are related to petroleum. So we have been active for a few years and would really like more of the membership who are associated with energy, especially in petroleum, to join our organization. Anyway, how many minutes do I have? 5 minutes. Okay, I'll do it very fast. I know that most of you are not familiar with petroleum, so I'll try to remove some of the technical discussions in my presentation, but I just want to present one aspect of petroleum that is really significant, and it is something that is taking more and more airspace amongst the oil-producing companies, and that is offshore production, and especially offshore EOR. Now, EOR stands for Enhanced Oil Recovery, and I'm going to explain what it really means. As I said, I'm not going to get into the details of this, but there is only one thing that I want you to know is on the vertical axis is the amount of oil that could be recovered from a place like Gulf of Mexico. And then on the x-axis is basically what we have are different technologies that we need to have in place in order to produce that amount of oil. So you can see that there is about 30 billion barrels, but the projected oil recovery is only 30%. In other words, we are leaving about 70% of oil in offshore environment. And the offshore is not the same as onshore, where you can get in anytime and recover that oil. Once you are done with primary production, you plug and abandon and leave, and that oil stays forever. Hence, you really need to do something if you want to produce that oil, and that the time is of essence. As like anything else, we are dependent on the oil price, and the oil price could impact what we can do in terms of EOR, enhanced oil recovery. And here are three scenarios that are there in terms of where we will be by year 2040. But you can see that low oil price is probably where we are going to be living on, in the $50, $60 for some time. And the other thing is cost of production. So there is one thing about having a technology that will give you lower cost, in other words, a more efficient technology. And another thing is also that technology should be environmentally friendly, because we are moving toward a time that we cannot just pollute the earth. We got to really sustain the environment. We got to really make sure that whatever we do, it is environmentally friendly and it is following the best principle in terms of optimization as well as best technology that you have available. So those are the kind of things that we need to do. And ignore this one, that's too technical. So one of the things that we are currently working within BHP, by the way, I forgot to mention, BHP Billiton Petroleum is an Australian company, and one-third of the revenue is coming from petroleum, the other two-thirds are coming from minerals, and the petroleum part is headquarters in Houston, and that's where I work. So anyway, what BHP Billiton is actually focusing on is some sort of a gas injection, such as natural gas, that you can inject and double the recovery. And this gas is interesting. This is gas that potentially is being flared offshore, or it's the gas they have to dispose of by several means, or a gas that is cheap. Right now, you're dealing with a gas that is costing $2 per MCF. Hence, if you take that gas, inject it into that reservoir, store it, and then produce your oil double, triple, or whatever you can get out of, at the same time, whenever the price of gas goes up, later you can come back and get that gas out. So that's one option. And the other one is could be CO2. CO2, you can actually collect it from onshore, bring it offshore, inject it, and just use that as CO2 storage. So there are so many ways of using an environmentally friendly technology that you can increase the recovery. It's being tested in several places, but in order to give you an idea of how large some of these reservoirs offshore Gulf of Mexico are, this is one of the fields that BHP is working in. It's called Shenzi. These are the structures that you see from top to bottom. And from top to bottom, basically the aerial coverage of this field is probably about 25 square miles. And each well that we drill is costing about $250 million. So the cost of development is huge. We are talking about between $5 to $10 billion cost of development. And that's why when you do a study like this, you got to really work your homework well before you actually implement any methodology there. So I just want to mention that there is a significant EOR resource there, and this is not just in Gulf of Mexico, it's everywhere. We are talking about Iran. The previous discussion that Pooya mentioned, EOR, is one of the things that Iran has to apply to their fields. They have a lot of aging infrastructure, a lot of aging fields. It requires a lot of new technology application and so on, and EOR is going to be one of them. And it's time for them to wake up and do work on it. And just to finalize this thing, as Amir Hossein mentioned, this is the book that we recently published with Professor Tony Kovcik, who is chairman of the Department of Petroleum Engineering here. And it is about low energy processes. And the concept of low energy processes is basically processes that are environmentally friendly, they are not energy intense, and they are actually about optimization of oil fields. Thank you.
All right, thank you very much for the very interesting talks. I think you did a great job because we have like 60 questions here. Okay.
We'll be here until tomorrow. Great.
Yeah, so I guess I'll go with the most popular one, probably the toughest one too, is, okay, what do you think in general the energy industry, many different sectors, can do to help fight climate change? And then more specifically, it is, do you see the oil industry as an obstacle to the path to renewable energy? And then what is the long-term transition plan for the large corporations? I think there's a more specific one for Mohammad, which is how does this data-driven technologies play a role here?
Right. So I think when it relates to environmentally friendly solutions, I just want to first talk about some of the essentially two important initiatives that are taking place in regards to environmentally friendly solutions, and Dr. Fassihi also briefly touched upon. One is the problem of CO2 storage. So we know that CO2 is the gas that essentially contributes the most to the problem of global warming and pollution. One of the areas that is both an active area of research but is also being tackled in operation is CO2 storage. So essentially what we do, we collect all the CO2 and we inject it into the reservoirs that are abandoned. These reservoirs provide a natural sealing and isolation for CO2. And essentially for CO2 to move throughout these reservoirs, it takes geological times. So we would at least make sure that the gas is trapped and stored within the ground and in the abandoned reservoir so that we are safe to some degree. In particular, I think in order to have both technical and commercial success for CO2 storage processes, there requires to be a lot of studies in terms of simulation of these processes. The physics that are involved is somewhat complicated to make sure that these processes are viable and essentially the gas that is trapped does not find its way out of these reservoirs. There has to be lots of studies, there has to be simulations. The data-driven solutions that I talked about, and I also in the second slide that I was showing, the sort of the proxy modeling is an active area of research that a lot of the companies are also pursuing. And what it does is that instead of doing high-fidelity numerical simulations where it can take tremendous amounts of time and effort and would also require expertise, you replace them with some sort of proxies. In order to go from those high-fidelity numerical simulations to proxy modeling, essentially you can take the data and leverage the data in order to realize what are the most important contributing factors to the physics of the process and simplify the physics. And that's one of the areas that there is some research going on, both in some oil and gas companies and academic institutions. The other area that also, again, Dr. Fassihi mentioned is the gas injection and simultaneous gas injection and EOR, or enhanced oil recovery, where again, the gas that is being flared and also contributes to perhaps pollution, you can take that, you can leverage that by injecting it into the reservoir, and at the same time maximize your recovery and also put that gas to use instead of flaring it and potentially corrupting the environment. So these are the two areas that I can think of. And again, the role of data-driven technologies in studying gas injection processes is very prominent. You can use data-driven solutions to come up with most efficient strategies for injecting gas and at the same time, again, increasing your recovery from the oil and gas reservoirs.
I feel like my panelists are definitely experts when it comes to the technological developments on the energy front. So what I would respond to that question is more on not necessarily the new technologies that are available, but rather some of the trends that I alluded to in the discussion in the beginning. But at the end of it is how we conserve and how do we bring about a culture of conservation before trying to find new ways of generating more energy.
Great, thank you very much.
Yeah, if I could.
So I was just going to ask if you could, because I know you have done a lot of research on the environmental aspects of energy production in Iran, especially, if you could add that too.
Sure, but let me briefly comment on this subject of gas injection because it's quite important for Iran. So most of Iran's gas is currently produced from a shared field called Pars Junubi, South Pars, which is shared with Qatar. So for Iran, it's actually quite important to, this gas injection into mature oil field is a very important issue because it can extract the gas from a shared field and then move it to the mainland, inject it to the oil fields that only belong to Iran, extract more oil, and then later on, when the oil is depleted, then you can use the gas again. So it's a very important topic for Iran. In terms of
Environmental considerations.
yeah, so again, natural gas, in my view, is going to be a very important fuel in the future, and Iran is lucky to have a lot of that because it's a bridge fuel in terms of carbon intensity, greenhouse gas emission. With the same amount of energy that it releases, it generates less amount of greenhouse gas. So in that, with that respect, it's very promising. As for the renewable energies in Iran, although I've done my PhD on renewable energies, I don't think, well, Iran has a lot of resources in terms of solar irradiation or wind speed. Iran has, it's very resourceful in that respect. But in terms of economics of that, with the amount of natural gas that Iran has, I don't think going heavily after renewable energy, solar, is probably in the best interest of the country. And we have done extensive analysis to show this.
Great.
Yeah.
Thank you very much, Pooya. So, Dr. Fassihi, maybe the more specific part of the question for you was that, is there a transition plan in like big industry champions? And I mean, maybe I can just say an example. I know that like Shell is right now one of the biggest wind energy producers in the world. So like not that many people know it, but they've invested heavily in wind. So is this a trend or is this the outlier?
Yeah, it's interesting. When I was working for BP, they started installing a lot of those windmills in West Texas. And then in offshore North Sea, some of the platforms that were about to be plugged and abandoned, as part of incentive, the government would allow the oil companies to go and install wind turbine on top of those platforms and just leave those platforms for longer time. So there is a trend that is moving toward using the existing infrastructure and create energy that is renewable. Within BHP also, there is this new initiative called sustainability. And the whole issue is, what kind of planet do we want to leave for our children? What are we going to do in terms of making it as clean as possible? And they are working on that in every project, looking at different aspects of environmental health, safety, and other things.
Great. Thank you
If I
very much.
may also add another point, again, going back to what I was talking about before, I think the role of technology, data, computation, and automation, we should not ignore that even when it comes to problems such as environmental sustainability. I'm sure all of you are familiar with the processes that is probably going in the industry, the whole fracking, and the shale gas and so on. Today, with the advancement of technology, we are actually able to follow and to simulate all of the contaminants that may or may not, as a result of this process, get into the ground. And by considering these solutions and by considering these advancements in technology, we will be able to, as we are right now, to change these processes in such a way that they are not environmentally unfriendly, if they are at all. So I just wanted to, again, emphasize on the role of technology and computation that has essentially changed the face of this industry, and it provides us with a means for coming up with solutions that are as viable as possible.
Great, thank you very much. So there's a lot of interesting questions, and we are the only thing standing between everyone and lunch. So I think I'm going to combine two of them, and then maybe you can pick whichever you like most and just answer that. So one very popular question is that, where do you see the biggest room for improvement and potential startups in the energy industry? And the second one is, from the student perspective, if you could go back many years and start planning your career and education again with all the perspective you have now, what would you do differently?
Okay. if you're looking for an industry that would be a good audience for improvement and efficient, and I say that in the nicest way possible, but oil and gas energy is the one. There is so much room for improvement, whether it be, again, picking up technology or, again, coming up with environmentally friendly solutions and so on. There's tons of ideas that I think we can work on as part of startups. Oil and gas industry is, again, an industry that has been very traditional, the way problems are approached. And when you're facing this kind of environment, you can essentially come and have a sales pitch for a lot of ideas to improve things. And the second question was?
If you could go back, would you do it
If I
again?
could go back. If I could go back, yes, I would do it again, but I would also try to strengthen some of my technical abilities, such as I would invest more in computer science. I mean, we're in an environment that is essentially the best place to pick up on that. I would try to strengthen some of my computer science capabilities.
So if I may add following good comments. So basically, I think energy industry is a high-tech, believe it or not, it's a high-tech industry. And a lot of development that are in the medical industry, we are using them. I mean, this whole ultrasound, microseismic, and I mean, this is the basic bread and butter for the oil industry, and a lot of other innovative things that have been happening in other fields. So it's a very tech-driven industry, and if you really like challenges, big challenges, really, petroleum industry is the place for you. I mean, that one of the offshore platform that I was mentioning, these are like as high as 5 of the Empire State Buildings. I mean, these are pretty tall structures and very reinforced and so on. So we are talking about massive scales. But in terms of your second question, if I restart, I definitely will do what I did. But remember, I came here from a very structured family. They said, you're going to be an engineer, and you're going to end up as an engineer. And I have enjoyed it. So when my son came here, I said, you're going to end up as an engineer. And after 2 years, he called me, he said, Dad, I have a bad news for you. I said, what is it? He said, I'm not going to be an engineer. Needless to say, he's in global development, okay? Not an engineering field, it's a completely different field. I have no idea what he's doing. So I would say the interesting thing about the previous presentations and also other startup companies that I've seen they are working on the technology field, really it's a great time for you guys that have so much liberty and freedom that you can go out of your common standard thing that they have planned for you and your parents have planned for you, and you can exceed and go and really go beyond anybody's imagination and come up with great products. I think that's really wonderful, and I really applaud all of you for that.
Good luck going against your parents' will.
I'll just add to what has already been said a little bit. So I come from a background that's more along the last panel, on more on the healthcare front. And while I was at Stanford, I took a whole lot of classes in entrepreneurship and healthcare, and in developing pitches for that, people would say, okay, if you get to a $1 billion market opportunity, that's good. That's what you want to hit, because otherwise VCs would not be listening to you. And so one of the greatest shocks of transferring out into this industry is you look at a tiny little problem and it's billions and billions of dollars of market opportunity. So it's a huge industry. It's more traditional than the other ones that we think about. But the impact can be tremendous. So if you're out there looking for opportunities for big impact, this is it. This is pretty good. If I were to go back and go back to the Stanford days, of course, if I knew what I know now and that I would end up in this industry, I probably would have taken some classes on this. But that's not to say that that's the most important part of it. What I would say, though, is that as somebody who starts a company, and I think this was something that Ali mentioned in the previous panel, is that there's so much you don't know, and there's an expectation that you have to end up knowing a whole lot of things. And so you go into the process knowing that you're not going to be an expert in anything that you're going to do. So any opportunity in school that would allow you to get exposed to areas outside of what you're currently doing, if you're more on the technical front, I would highly recommend that you look more to the business front as well and try to take classes there and try to diversify your education while you're at Stanford. That's a great place.
Well, I'm not in the industry, so I don't want to ruin anyone's future. So I myself had a very unconventional path or career path. So I'm a chemist, currently working at the Iranian Studies department at Stanford, looking into population trends in Iran. And I think that says everything about me. So I really don't want to ruin anyone's future by my wrong comments about this. But I personally believe that the future of energy will be mostly on how we store the energy. Batteries, for example, is one way. If you're thinking about going back to Iran, definitely natural gas is the future. If you're thinking of staying here, working in the energy industry, in places like California, energy storage, I would recommend, is the right field to dive into. That's everything I have to say.
Great. Thank you all very much. It was an honor for me to sit here next to you. And thank you very much for accepting our invitation.
Thank you.
Thank you.